This is a recording for linear approximation. I'm using figure 4.22 in your textbook. Linear approximation is what the name is saying. Linear, line, approximation, estimate, or estimate. So using a line to estimate something. Now to the curve, or figure 4.22. As you can see, this is the curve where we have y equal fx, or you call it fx. And if we input x here, we get this point from this function. And we call this x, f of x, right? Okay. Now, this point here is an increase from x. And we call this delta x. That's the difference between these 2 points. And if we input x plus change in x into this function, we should get this point here. We call this x plus delta x bracket f x plus delta x. Okay, so what is this point, and basically what is the change? What we're interested in is the change of y. So the rise. We know the run. What is the rise? Okay. We could do this by taking the derivative of this function. By doing that, we get the tangent line at this point. So we take the derivative of this. By taking the derivative, we get a tangent line at this point by plugging in x in that derivative function. We get this line, right? And if we plug this x into that function, note that it's not exactly this point that we're measuring. We're measuring something close to it, i.e. approximate where that point is. So when we do plug this in the derivative of this function, we are measuring this point here. We gain this point. Well, what do I mean by getting, how do I get that point? Well, because we have a slope from the tangent line when we take the function of f of x and we take a derivative of it, we get a slope, right, at this point of x. So we get a slope. No, slope is, ignore this, rise divided by run. So we get a slope and we times it by the change in run. In other words, delta x. We could get the rise, how high this is, or how high this went up by. And if we put it all together, this is the equation, right, for linear approximation. fx, what we did was, if we plug in fx into the original function, we get this point. So we get the point x bracket f of x, right? That's that part of linear approximation. As I said before, by taking the derivative of this function, we get the slope. So this is basically getting the slope of this function. So we got add slope. That's what this part is. And we get the change in x. The change in x, as I said down here, ignore this. The reason why I have this here is x minus 1 times x. We could, instead of having these points as x and x plus delta x, the change here, we could say this is x naught, the original point, and x1, the point that we're interested in. So we could go x minus 1. But just going along with what I had before, I could just put delta x here, which is what we have. So delta x, if, for example, say x was 2, and the change in x was 0.2, then it must be that this point here is 2.2, right? Okay. And that's how you get linear approximation. Once again, it's approximation. So you're getting really this point here, which is away from the actual point on the curve.